right, looking at the top of page 359, the student-to-student section has a good reminder for how to keep straight how the 30, 60, 90 triangle works. This student says, to remember the side relationships in a 30, 60, 90 triangle, I draw a simple 1, 2 radical 3 triangle like this, or a 30, 60, 90 triangle like this. He reminds himself that if the shortest side were 1, then the hypotenuse would simply be 2, because the hypotenuse is twice the shorter side. And he reminds himself that the longer side would simply be radical 3, because remember, the longer side is always the shorter side times radical 3. So in this case, 1 times radical 3 would be radical 3. So just for memorizing these relationships, that might be helpful to you, because this shows you the relationship between the sides. Okay, moving on to this example. Using the 30, 60, 90 triangle theorem, I want to show you what they've done here. I'll read you the problem. The frame of the clock shown is an equilateral triangle. The length of one side of the frame is 20 centimeters. Will the clock fit on a shelf that's 18 centimeters below the shelf above it? Well, let's work our way through this. We're going to divide this equilateral triangle into two 30, 60, 90 triangles simply by drawing a line right down the middle that's perpendicular. So we're drawing an altitude here that runs from the vertice perpendicularly to the opposite side. And that's, remember, an equilateral triangle is also going to be equiangular. So in the beginning, this was 60 degrees, 60 degrees, and 60 degrees. We're still going to have 60 degrees here and here, but because we divided this, bisected this top angle, this side is going to be 30, and this side's going to be 30. So we've created a 30, 60, 90 triangle here, and we've also created a 30, 60, 90 triangle here. All right. They also told us that the sides are 20 centimeters each. So we have 20 and 20. What they would like for us to do is find the length of the shortest side here, and then find the length of, so here would be our shorter side. I'm sorry. What we're given is our hypotenuse when we've broken this up into half of the big triangle and made a smaller triangle. We've got shorter side, hypotenuse, and longer side. So first they want us to find the shorter side, then they want us to find the longer side. Well, let's simply use the math that we've been doing, knowing our relationship. We know that our shorter side is going to be half the longer side. So x is going to be 10. That's going to be true in both of these triangles. And we know that our longer side is always in a 30, 60, 90 triangle going to be the shorter side times radical 3. So in this case, that's going to be 10 radical 3. So this longer side is going to be 10 radical 3. And what they want us to be able to tell is, will this clock fit on a shelf that gives 18 centimeters of clearance? Well, our triangle is 10 radical 3. We need to use a calculator to find out what 10 radical 3 really is. And I actually need to grab my calculator. Bear with me. So what we do is we plug 10 radical 3 into the calculator and press equals. So let me show you how I did that. We take our calculator, and mine is a little bit more complicated than the calculator possibly that some of you will be using, but you look at this and you say, okay, I'm going to put in 10. This isn't working real well, so I'm just going to need to hold it. I put in 10, and now I have to put in radical 3. On my calculator, that square root sign is the blue right there, so I need to use like my shift or my second and my square root sign, and then I'll put in 3. So even that parenthesis, even though the parenthesis is there, this still says 10 square root of 3. And then I simply press equals. And that tells me that 10 square root of 3 is the same as 17.32. So that means that this longer side of my small triangle is 17.3. We're going to stop there. Will that fit on a shelf that has, what was it, 18 centimeters of clearance? Yes, it will. So by solving for the height of our small triangle, or the longer leg, we were able to find out exactly how tall, even to a 10th degree and further than that, the clock is, and then we're able to tell whether it will fit on an 18 centimeter shelf, and the answer is yes. So again, let's review how we changed from 10 radical 3 to 17.3. We simply put 10 square root of 3 into our calculator, and it equaled 17.3. That's all I did. 10 square root of 3 equals, and then it told me the accurate decimal number. You will not need that for your homework today, but I do want you to have that tool in your arsenal. And I think that's all for today. I hope you have a great weekend. Y'all let me know if you have questions, and I will go get these last two videos uploaded. Bye-bye.